Good day, everyone. I'm here to present our research entitled Neural Network-Based Sensitivity Analysis of the Factors Affecting the Solar Photovoltaic Power Output. To start with our introduction, the objective of our study is to do a research wherein we will assess how the solar PV production is affected by the factors such as the solar irradiance, the rainfall, the maximum and the lowest temperature, wind speed, and the relative humidity. Using the machine learning-based sensitivity analysis through Garson algorithm. According to the Department of Energy of the Philippines, Government Power Situate a report of a total about 107,000 gigawatts of power were utilized in the country with the distribution of electricity usage in the Philippines, which is shown in the figures. The study is in line with the transition of different industries to Industry 4.0 or the Fourth Industrial Revolution, wherein the big data, Internet of Things, and artificial intelligence were broadly utilized. The study implemented the AI part of the Industry 4.0 using a neural network-based sensitivity analysis for determining the influence of the parameters affecting the solar photovoltaic power output. There are some research such as Shati G and Pandya 2016 wherein in the research they use AI technologies and applied for extracting patterns. It is also used in establishing functional relationships between inputs and outputs. It also uses a machine learning, and then they use it as a prediction of recurring phenomena based on a time series. So for the artificial intelligence models, we have a neural network, genetic algorithm, fuzzy logic, and other AI models. So here in the figure, as you can see, it is the architecture of a neural network. Okay, for our methodology, the study implement a three-tier process, including the ANN modeling, weights and biases generation, and calculation of relative importance through sensitivity analysis by Garson's algorithm. So for our data collection, so the Pag-asa provided the input parameters including meteorological data on the solar irradiance, wind speed, maximum and minimum temperature, rainfall, and relative humidity. While the PV monitoring system of a 77 kilowatt grid-tied connected PV system located in the Allied Local Emergency Response Center, or what we call the ALERT, provided the output data. All in all, a total of 755 arrays or dataset with a complete set of input and output parameters were gathered over the course of a 150 days for the datasheet, or the 150 days of monitoring. The ANN model development includes the use of Levenberg-Marquardt as the training algorithm, the hyperbolic tangent sigmoid as the transfer function, and the RNMSE as a performance indicator. So the ideal value for R is equal to 1, while the MSE is equal to 0, which is used to determine the governing model. The relative importance using Garson's algorithm, using the weights and biases from the governing ANN model, the relative importance was calculated using the Garson's algorithm. So basically, the table presented shows the descriptive statistic of the datasets used in modeling process. So we have the parameters wherein we are using the solar irradiance. We have the rainfall, the maximum temperature, as well as the minimum temperature. It also includes the wind speed and the relative humidity as the input value, while we have the solar PV output as the output parameter. So for the maximum value, the minimum value, and average value, it was also included in the table shown. correlation matrix was employed to generate and illustrate the correlation between the parameters used in the model development. The result indicates that the solar radiation and the maximum temperature have a positive association with solar PV production, but relative humidity and rainfall have a negative correlation. So for the result and discussion, the ANN modeling simulation result shows that the governing internal characteristic of the ANN model, which uses or includes Leavenberg-Marquardt as the training algorithm, the Tansig function as the transfer function, and a 681 input hidden output as the network topology. Using the network weights, the relative importance of the solar PV output factors were calculated. It was observed that solar irradiance is the most influential factor, while wind speed is the least influential factor to the solar PV output model. So for our conclusion, the solar irradiance and the maximum temperature had a strong relationship with the solar PV output. The 681 configuration was shown to be the optimal topology for the neural network-based solar PV output model. And last, the ranking of the factors that affects the solar PV system output was calculated to be the solar irradiance as the highest and the maximum temperature, minimum temperature, rainfall, and wind speed as the lowest. So that's all and thank you very much.